Hi guys, so I'm going to make a video about lesson 3.1 for Math 98, and this is what we did on Monday in our class, in our Zoom class, and then the second part of this week, the second and third class this week, we'll be doing the two parts of 3.2. So I just wanted to take a minute to mention that throughout Module 3, we're going to be doing something called dimensional analysis, which is what we're going to be doing in class today in this video. And it's a little bit tricky sometimes for people, and I'm just asking you to kind of trust me and keep at it, and we'll get lots of practice during Module 3. Some of the problems that we do, you might say, well, I can do this using other methods other than dimensional analysis, which is true, but I'm asking you to use this method for now so that you get used to it and so that you get practice at it. Okay. And I actually did have a student from last semester who is currently in chemistry. She's trying to get into the nursing program. And she emailed me a few weeks ago to say that, the things we learned in Math 98 were helping her so much, and she specifically mentioned dimensional analysis. So it really is useful in other classes. So I'm just going to kind of ask you to, as I said, just hang with me, trust me, as we go through this that might seem a little bit new to you. Okay, so if you look at your book, we're on page 311 in your textbook, lesson 3.1. And if you have not already done the P&L for 3.1, I would ask you to do that, please. And the P&Ls for 3.1 and 3.2 are due this Friday night. All right, so under problem situation, it says dimensional analysis is a method of setting up problems that involves converting between different units of measurement. It is also called unit analysis or unit conversion. Many professionals, including pharmacists, dietitians, lab technicians, and nurses, use dimensional analysis. It is also useful for everyday conversions in cooking, finances, and currency exchanges. Many people can do simple conversions without dimensional analysis. However, they will likely make mistakes on more complex problems. The advantage of using dimensional analysis is that it is a way to check your calculations. While it is always important that you develop your own methods to solve problems, this is a time when you are encouraged to learn and use a specific method. Once you have learned dimensional analysis, you can decide when to use it and when to use other methods. Okay, so if you look at the bottom of that page, there's two questions there. The first one says, according to Toyota's website, a 2014 Prius can get an estimated 51 miles per gallon in the city and 48 miles per gallon on the highway. How many miles will you be able to drive in the city if you have 4.5 gallons of gas? And then you can see part B says how many gallons of gas will you need to drive 3,450 miles. Now for that one, it doesn't specifically say whether it's city or highway, so let's go ahead and assume that it's city. Okay. So what I'd like you to do is pause the video for a minute and see about figuring those out. Don't worry about dimensional analysis. We haven't talked about that yet. Just think about how you would figure out those two problems. Okay, so for the first part, for part A, it said that the Prius can get 51 miles per gallon in the city, and we're using the city in our problem here. And how many miles will you be able to drive if you have 4.5 gallons of gas? Okay. So many of you probably realize that one way to do this is to multiply 51 miles per gallon times 4.5 gallons. Okay. So let's think about why this is. If we just have like a silly little visual, if this is a gallon of gas, then this can take me 51 miles. I don't just have 1 gallon of gas, I have 4.5 gallons of gas. So here are my 4 gallons of gas, and then here's my half a gallon. So this one can take me 51 miles, and then half of 51, which would be 25.5. So whenever we multiply, or whenever we add something over and over and over, the same thing, that is multiplying. So I take 51 4.5 times. When I do this, I would get 229.5 miles. Okay. For part B, we want to drive 3,450 miles. And again, we said let's assume it's in the city. So again, if you want to think of a silly little visual here, this box represents all those miles of driving. Well, every time I drive 51 miles, I need 1 gallon of gas, right? So if I could split this up, if I could subtract 51 over and over and over again, or if I could split it up into groups of 51 to see how many groups of 51 I have, because each group of 51 is 1 gallon, if I'm dividing it up like that, that's division. So if I take 3,450 and I divide by 51, see how many groups of 51 there are. If we round it, we would get 67.6 gallons. Okay, so many of you may have been able to figure those out, realizing that we needed to multiply here and divide here. Okay. But sometimes it's hard to figure that out. If this were a little bit more complex problem, or for some of you, maybe you couldn't figure out which operation to use. And this is where dimensional analysis starts coming in. Okay, it helps us decide. We don't have to decide actually when we multiply, when we divide. The dimensional analysis helps us set up the problem in such a way that we don't think about that. The problem is set up the correct way for us. So let's take a look at this. So on page 312 in your book, there's actually a sample problem and all the work is written out, but I'm going to go through that one. So I would say you could just put your pencil down for a few minutes. I'm going to be doing what's in the book, but we're going to do it up here and kind of talk about it step by step. All right, so the problem is your paycheck for 2 weeks comes out to $1,200. Okay, so you get $1,200 for 2 weeks of pay. We work, or you work, this person works, 5 days per week, and they work 8 hours per day. Okay. So if this is the case, how many cents per minute do you make? Okay, so that's the question we're trying to answer right here, is how many cents per minute? You know that your paycheck is $1,200 for 2 weeks. Well, how much am I making every minute? Okay, so this is an example again where I could multiply or divide in some cases along the way. It might be a little bit tricky to figure that out. I'm going to try turning this light on, see if it makes it a little lighter in here. So it might be a little tricky to figure out. So we're going to use dimensional analysis as a way to set this up. Okay, dimension means measurement, like the dimensions of your room. So the dimensions are the units or the measurements, and we're going to use those to help us set this up. So what we're going to do is we always want to figure out first what units our answer is going to be in, which is a good thing to do no matter what kind of method you're using. If I don't know my units of my answer, I don't really know where I'm headed. So I want to know my answer is going to be that I make blah, blah, blah cents per minute, right? So our unit is going to be cents per minute. Okay, so I'm going to start knowing that that's my goal. So when I start out here, way over here, I'm going to start out with something that has cents in the top. And when we do dimensional analysis, we're going to have a series of factors that compare one unit to another as we're changing them. So when I look over here, I don't see anything about cents. Okay, but sort of outside information that I can pull in, I see something about dollars, and I know that dollars and cents are related. So if I want to start with something about cents here, I'm going to say that I know 100 cents is $1. And that's related to this somehow, because I'm starting out with dollars and I have to get down to cents. Okay, so this is just a piece of information that is always true. 100 cents equals $1. Now I also could have said $1 equals 100 cents. That's true, however, that would have given me cents in the bottom in my denominator, and I want it in my numerator over here. So I always want to start out where the numerator is what I want to end up with. Okay, now if you look at this, do I want dollars in my answer? I don't. There's no dollar sign in that answer. So I'm going to multiply by another factor here, another ratio, a conversion factor. And it's going to be in such a way that dollars is on top. So I'm going to have something on top here for dollars. And I think about, or I look at what other information I have, and I know that I make $1,200 every 2 weeks. Okay, so let's pause for just a minute. If you think back to the P&L for 3.1, there was a lot in there about fractions. So if you remember, let's say I'm multiplying fractions, and I'm going to multiply 1/2 times 2/5. I could either multiply straight across the top and straight across the bottom and get 2/10, or I can look for numbers that have a common factor, one in the numerator, one in the denominator, that can cancel out. In this case, it's the 2's. 2 goes into 2 once, 2 goes into 2 once. They can cancel out, right? One on top, one on the bottom. It's the same idea here, but we are going to be doing it for the units, not for the actual numbers. So because dollars is here and dollars is up here, they cancel out. I don't have dollars anymore in my heading toward my answer. Okay, I have cents per week now. Do I want weeks in my answer? No, I want minutes. So week is a big unit of time, right? So I'm at least in time, but I want to work my way down to minutes. So I know that I need to multiply by a conversion factor that has weeks on the top, because I want weeks to cancel out. So if it's in the denominator, I need to multiply it by something up on top. So I already used this, right? What else do I have? Well, I know that I have weeks and days. So the reason it says 5 days per week is because this goes along with a work paycheck. So even though there are 7 days in a week, in 1 week I'm only working 5 days. I'm only getting paid for 5 days of work. So this is good because my weeks and weeks cancel out. So do you see how, here I'm multiplying by this. Here essentially I'm dividing by 5, but I don't have to think about which one I'm doing. I'm just multiplying everything, and the units are telling me what goes on top and what goes on the bottom, and it's just going to be set up perfectly at the end to get my answer. Okay, do I want days in my answer? No, right? I want minutes. So that means days, or in this case it's going to be a day, is going to go on the top so that the days cancel out. Well, what do I know about days? Well, 1 day of work is 8 hours. I put days on top so it would cancel out. So 1 day is 8 hours. Okay, do I want hours in my answer? No, I want minutes. Okay, there's nothing over here about minutes in terms of information. But again, this is a situation where we can pull in outside information. These 3 factors are full of information that goes specifically with this problem. This factor and what we're going to put next is information that's true always. How are hours and minutes related? Well, I put hours up here. 1 hour is 60 minutes. So I can cancel this out. Okay. Now, if I look at my units, I've gotten the units I want. Everything is canceled out except for cents on the top and minutes on the bottom, which is exactly what I want over there. Okay. If I multiply straight across the top and straight across the bottom, so I'm just going to erase this from here so we have a little more space. Okay. I would get 1,200 times 100, so 120,000 on top. And I get 4,800 on the bottom. So if I think about my units, this is saying 120,000 cents over 4,800 minutes. This is how many cents I make in this many minutes. That doesn't really mean a lot to me in my brain, right? So I'm going to divide this. And when I divide those two numbers, I get 25 cents per minute. Okay, I'm going to stop the video here just because I'm about to run out of time for it to be short enough to upload, but I will start another video in just 1 second.